We all know how expensive using these models could be, which is why caching is one of the most important things for you to learn as an AI developer. In this video, we're going to be covering Gemini's caching capabilities. We're going to be talking about the two types of caching, implicit caching and explicit caching. At the end of this video, you will have the prerequisite to build powerful applications using all the things we've previously talked about and the things that we're going to talk about in the remaining videos. If you're new here, I'm Engineer Temi, and we've been diving deeper into Gemini's Python API and how to use it in applications. If there's anything you don't understand or something you want me to cover, please leave a comment. I'm always ready to explain things deeper because they also help me understand. As usual, the code is in the description. Please grab it, try it out. But right now, let's dive into the video.
Hi guys, in this tutorial, we'll be taking a look at context caching in Gemini, what it is, why you'd want to use it, and how context caching can be done in Python. Thank you so much for watching so far. Let's get into the video. So as usual guys, the link to the code and the notebook will be in the description. Please try it out yourself, as this is the way you'll be able to learn and practice. We will be starting out with our setup, just taking a look at all the packages that we would need, the model we'll be using. Then we'll have a quick conversation on what context caching is, why you want to use it, how to use it, and I will just go through some limitations that I've found and some limitations covered in the documentation, and we'll just have a quick recap and end the video there. So for setup, we'll be using the Gemini Gen AI Python library. And here I just import a couple of packages that we would need. And then I specify my Gemini API key. Before I forget, to run this notebook, you will need access to the Google API key, which you can provision directly from the notebook. And don't forget to grant it access. For our other tutorials, we've needed drive access, but for the purpose of this tutorial, we won't be needing drive access, so you don't need to grant the notebook access to your drive. So if I just run this here, we will see to install the package. One thing I want you to note is that when you're using context caching in Gemini, you need to specify the model version that you want to use. So for example, we'll be making use of Gemini 2.0, and you can specify the model version by appending a dash and then dash 001, for example, as the model version. In the next section of this tutorial, we'll be taking a look at what context caching is. Let's get there. So context caching, before we get into what context caching is, let's just discuss what caching in general is. And as many of us know, caching is the process of storing frequently accessed data in a temporary storage location to reduce retrieval time and improve performance. Say, think for example, Redis is a cache and you're building an application that frequently accesses data from the database or your persistent store, but to improve performance, you store this frequently accessed data in the cache so that anytime requests come in, you go straight to the cache because the cache and the data is stored in the RAM, and this guarantees faster access than you storing it on the disk, which is what most database or file storage are built upon. So what is context caching? Well, it is the process of storing context, also known as input tokens, of your request to Gemini to reduce cost and improve performance. If this did not make any sense, this is the way in which when you're interacting with Gemini, either through the API or I'm sure, for example, even the AI Studio, they apply this. If you have data or input tokens that you frequently send to Gemini, say, for example, you keep analyzing a text document over and over again, trying to break it down, or even a video file, you could create a context cache, and this is where you give Gemini information or the entire information once, and then you send it out to Gemini. It is cached, and then in further requests, you could reference that cached data. This is how explicit caching works, but generally, Gemini ships with two types of caching. We have the implicit caching and the explicit caching. You don't need to do anything to turn on implicit caching, as Gemini configures this by default for you on all 2.5 models. And for you to increase the chances of an implicit cache just means Gemini handles this automatically. If you formatted your inputs to Gemini in a way where a part of the input is always the same across board, say for example, your system instruction is so large, but it is always the same thing, by default, Gemini will ensure that this is implicitly cached. And it says here, to increase the chance of an implicit cache hit, try putting large and common content at the beginning of your prompt, try to send requests with similar prefix in a short amount of time. This is how implicit caching could be enabled, and the source I just put it here in Gemini. And let's just go over what explicit caching is. So this is a feature that allows you to pass some context to the model once, have it cache the input token, and then refer to the cache content for subsequent requests. Like I explained previously, all you just need to do is create a cache once with your context or your input tokens, and in further requests, you could then reference that. Let me give you a very good example to hit this home. Say we're building a video analysis platform where users can upload videos and then we give them information about those videos. Say, for example, we wanted to show them how many times users in the video looked directly into the camera, and you wanted to do, in addition to this, you wanted to analyze the colors of the dresses of people in the video. It doesn't make sense for you to continuously upload this video at every point of the request. What you could do instead is to send the video file once to Gemini for it to cache it, and then in your subsequent requests or every interaction of the user with your application, you can then reference the cache content in the request. That is what explicit caching is, and let me explain why this is so important. Because using models like Gemini, like OpenAI, like Claude come at a very, very high cost, especially when you're building applications that use millions or even billions of tokens. And because of this, explicit caching is introduced to help you save costs, so that if you have data that you frequently use in your request, by caching this once, this could reduce your cost by 50%. And I put here, when you would want to use this, you are building an application that requires Gemini to have extensive knowledge of the interaction. Like I just previously explained, you're building a video analysis platform, you're building tools that should interact with large corpus of text, and there's many, many more applications. But enough of text or enough of explanation. Let's look at code, because we're all developers here and I don't want to waste your time further. One of the steps that is involved in explicit caching is that you first need to upload a file. In our previous tutorials, we've covered how to do file uploads in Gemini. I will link the video here, or yeah, please watch it if you don't understand, but I'm not going to explain this. And all we do here is we will pass some content from the drive. I previously said we won't need the drive here, but that is my mistake. So let me quickly grant drive access. Oh, and I see here I've already granted drive access while I was testing this out. And so we can successfully run this, and that should basically upload this file to Gemini, and then we just need to check if the file is still processing. I see here that the file has successfully been uploaded, and then the next thing is using the caches.create API, you would pass the model, you will pass a config. Say for example, the display name is notebook LLM, and you pass a system instruction when you're creating your cache. And my system instruction here is you are an expert audio analyzer, and your job is to answer the user's query based on the audio file. So you see, I create my cache, I pass it a system instruction that would be used across all the further requests to Gemini, and I pass a TTL of about 5 minutes, because this is a quick workflow that we'll be using. And if I just run this here, this should successfully create a cache, and then in requests further down the line, I can then reference this cache to Gemini and then start querying. And now for the first request, I say, how many speakers can you identify from the audio file? What information did they represent? And do you agree with their take? This is just an audio file we've used previously, where two speakers are discussing the power of doing instead of just reading or consuming knowledge. And if I run this, and I just also want us to print the usage metadata and the text we get. And if I run this, we should see that Gemini should produce a response to us using the cache and also the new content that we specified. And we see here that for cache token details, the media modality is text, the token count is 30. That means this is what we passed here, and also the system instructions that we passed. So it also cached that. It cached an audio file, and it cached the other text that we provided. And then in the response text, we see here it successfully identified that there are two speakers in the audio file, and they discuss the importance of practicing and learning and skill development. And it also specified a section here that it finds their take very insightful and valid, and their emphasis on the crucial role of active practice in mastering any skill. So this is how you would create a cache and then also use the cache in basically your request to Gemini. But let me show you how you could then list all the possible caches that you've created. So you just need to run this, and this will tell you all the cache that we've created. And we see here that we have a display name of notebook LLM, which is what we specified in the display name here. Say for example, we set a TTL of 5 minutes, but for some reason that is not enough for you to complete your workflow in the future. One thing that you could do is that you could update the cache entry and update the TTL value, and this would then extend the TTL of your cache entry. So if I do this, we see that we get some information of when the cache was created and the expiry time, which is 5 minutes into the future. But say for example, you don't want to use TTL and you know a specific time that you want this cache to expire. Say for example, I want this cache to expire in 10 minutes. All you just need to do is use the datetime library and specify now add your 10 minutes and then pass that as expire time. Notice the difference here. We use expire time and here we use a TTL value, which is just the time in seconds. And then if I set this, we see it also updates this. The expiry time previously was 10/7/39, but if we see this, it has extended it to 10/13/19, which is about 10 minutes into the future. Now, say for example, you're done with everything that you wanted to use a cache for and you wanted to delete your cache, because the amount of time you store your cache also factors into the cost, including your input tokens. All you need to do is use the cache to delete and pass it the cache name, and that should successfully delete the cache. So limitations. One of the limitations is that the minimum input token count for context caching is about 1024 input tokens for 2.5 flash and 2048 for 2.5 pro, and the maximum is the maximum for any model chosen. So what this means is that the maximum tokens that could be cached is the maximum context size that these models could ingest, but for the minimum is about 1024 for 2.5 and 2048 for 2.5 pro. Like I said previously, you also use an explicit model version, and by default the TTL is 1 hour, and the billing for explicit caching is determined based on the input token usage. So even if you're still caching, there's still some cost that is associated with this, but the beauty of this is that the cost is reduced by 50% because you've created a cache once and you're just using the cache content in your request. And also the cache duration also factors in to the cost. And here I just give you some general information that for every video file you upload, there is about 2.63 tokens per second, meaning that if there are 263 tokens per every second of video, if you're using any of these models, that means the minimum time of any video file that you could cache is about 7 seconds, and for audio is about 32 tokens per second, meaning that you need at least a minute of audio data to be cached. Guys, if you made it to the end here, thank you so much. Let's go through some recap. So we covered implicit and explicit caching. We covered making a request with cache content, and we also explained when we would want to use the cache. For example, we have repetitive analysis of lengthy video files, recurring queries against large document sets, or we want to create a complex system prompt for a multi-agent workflow. These are building blocks you'll come back to again and again. Thank you so much for watching. If you like this video, please like it, share it with a friend, turn on post notification. If there's anything I didn't explain well that you'd like me to cover again, or something you want me to make a video on, please leave a comment in the description. It means so much to me. Thank you so much, and I'll see you in the next video.